Okay guys, so to wrap up our short series on the inverse functions, we're going to wrap it up with our fun problem. So it says consider the one-to-one function f of x. We want to find f inverse of x, so we want to find f inverse. And again, depending on your book, you may see it f inverse of x, or it may just say f inverse, but same difference. Okay, so how are we going to find the equation of the inverse? The first thing that we want to do is get out of function notation. So we're going to replace f of x with y, and that will leave us with 1/2 times the square root of x plus 3. Now, what is the property of inverse functions? So if f is a one-to-one function, and if AB is in f, to find the inverse, we're just going to reverse the order of the ordered pair. So if AB is in F, then BA will be on the inverse. So on that note, to find the equation of the inverse, we're just going to reverse all the ordered pairs. So in order to do that, we are going to interchange X and Y. So in this case, we have a Y, which we are swapping for X. So that will give us X equals 1/2 times the square root of X, which we're swapping out for Y, plus 3. So again, to find the equation of the inverse, 1, assuming that you have a one-to-one function, 1, get out of function notation. 2, we trade places, interchange x and y. 3, solve for y. And then 4, go ahead, use your proper notation. Go ahead, use the inverse notation. So let's go ahead, in this case we have a radical notation, so let's go ahead isolate the radical. To get rid of the 1/2, let's go ahead multiply both sides by 2. Let me go ahead put this in parentheses. And when we do that, will give us 2x is equal to quotient of 2 and itself will give us 1, and that will give us a square root of y plus 3. To undo the square root, we're going to go ahead raise both sides to some power equal to the index. So in this case, because the index is 2, we're going to raise both sides to the second power, or we just say square, same difference. The square of 2x times 2x will give you 4x squared, and on the right side, the square and the square root undo each other, and that will leave you with y plus 3. So let's take it away. Let's go ahead solve for y. After we subtract 3 from both sides, that will give us y equals 4x squared minus 3. I'm out of space, so let me go ahead and write this over. I'm going to switch the y on the other side. So y equals 4x squared minus 3, but if we leave it as y equals, no one will know that this is the equation of the inverse. So we have to use the proper syntax, okay, proper notation. F inverse, sorry for that really long one, okay, F inverse equals 4x squared minus 3. And I know we nailed the algebra, but just because we nailed the algebra doesn't mean we're good to go. We have to make sure that this is also a one-to-one function. So let me speak to myself. Is this one-to-one? Cool. And then I'm going to speak to myself, use calculator. So let's go ahead and use our calculator to quickly verify if it's one-to-one. I'm crossing my fingers hoping that it is, because if not, I'm going to have a moment because we're going to have to restrict the domain. Okay, so let's go ahead and graph it. So we have y equals 4x squared minus 3. Oh, sorry about that. Technical difficulties. Put that in the blooper. All right, cool. Let's go ahead and graph it. And it's like, oh, is this a one-to-one function? So to determine if a graph is a one-to-one function, we're going to go ahead and use the horizontal line test. So we're going to take our horizontal line, slide it across, and make sure it doesn't touch the graph in no more than one place at any given time. So let's go ahead and do that in slow motion. So I do it from top to bottom, or however you're reading it. I'm reading it from this top part, okay? So I'm sliding my horizontal line, and looks like this graph does not pass the horizontal line test. So it is not one-to-one. So let me go ahead and sketch that for us, okay? So the graph looks like this. I lost my place, okay? It looks like this, something like that, and this is not one-to-one. So I speak to myself, one-to-one. So that means we're going to have to restrict the domain on our inverse. So with your permission, we're going to go ahead, take a look at the original function, identify the domain and range. We'll swap places, and then we'll see what the domain of the inverse should be. Okay, so for the original function, we have f of x equals 1/2 times the square root of x plus 3. The domain is all acceptable values. So in this case, we have a radical function with even index. So we have to make sure that our radicand is non-negative. Okay, so the domain, all acceptable x values, so all real numbers except for those that make the radicand negative. So if I want to know what makes the radicand negative, or pretty much, let me say it backwards. So it's all real numbers except for those that make the radicand negative. So the only way that I'm going to ensure that the radicand is not negative is if we tell the reader, hey reader, you can't be negative. Using mathematical symbols, we say, hey reader, radicand has to be at least 0. Okay, so we go ahead, solve for x. When we subtract 3 from both sides, that will give us that x is greater than or equal to -3. So the domain is all the numbers that are greater than or equal to -3. But how would that look like in interval notation? I know you guys are on it, but for me it's really hard to go to the interval. So we're just gonna graph the element in the domain. -3 is part of the domain as long as the numbers that are bigger. So interval notation goes from left to right. So where am I? We start at -3 and pull towards the positive direction. Okay, so in interval notation, the domain of f is given by the interval from -3 to infinity, where -3 is excluded. Now, what about the range? The range, we're going to go ahead, use the graph. Let me go ahead, clear this. Okay, so the graph of our function, we have 1/2 times, you don't need the times, it's just out of habit, times the square root of x plus 3. We're going to go ahead and graph it, and it's a nice way to confirm what the domain is. The domain we said is from -3 to infinity. That looks like -3, 1, 2, 3, and that looks like -3 to infinity. The range, the lowest value will be at this point, which will be 0. Value of the function is 0 up to infinity. Cool. All right, so the lowest value of y is 0 up to the highest value of y, which is infinity. So in this case, remember, to find the inverse, we're going to reverse all the ordered pairs in f. So in this case, the x's become the y's and the y's become the x's. So the domain becomes the range of the inverse. Where am I? Oh, sorry, wrong letter. Okay, and you cannot see that, sorry. Okay, so the domain becomes the range of the inverse, which is the interval from -3 to infinity, and the range becomes the domain of the inverse. So on that note, so my solution that I wrote above is a little bit too high. We had said that the inverse is given by 4x squared minus 3. And in this case, thanks to our hard work, we have the domain, where the domain is given by the interval from 0 to infinity. Depending on the book, your book may say where x is greater than or equal to 0. Okay, guys, you guys are awesome. Thank you.